Welcome to Methamphetamine. Today we're gonna do the integral of Ln power of n x goes from 0 to 1. Or you can say it as from 0 to 1. So going from 0 to 1. Okay. First, Ln power of n x is actually has the pattern. I will leave these answers at the end. So first step, we're gonna figure out what is the integral of Ln x dx going from 0 to 1. And you know this a really famous question. The integral of Ln x is just Ln x times Ln x minus x, right? But I'm going to show you how to do this. We're gonna use our integration by part, put the dI here, d and I, and then we're gonna differentiate Ln x and then integrate 1. Integrate 1, you get x. Differentiate Ln x, you get 1 over x. So far, this time that is the first part of the answers. So this x times Ln x, and then don't forget to put 0 and 1 into it. And then subtract the integral of this product. And then 1 over x and x, the x and x, they are cancelled. So you get 1 here, 1 dx, and then go from 0 to 1. Like that. So over this one is the important thing. If you put 1 into it, you get Ln 1, and 0 times 1 over, you just get 0. However, whenever you put 0 into the Ln, you get Ln 0. Let me show the graph of Ln x to you guys. The Ln x graph like this is approaching to negative infinity. When x is approaches 0, is approaching negative infinity. Y is 0 to Ln x. Like that. So over Ln 0 here is just negative infinity, and then 0 times negative infinity is an indeterminate form. So we have to use our Loss-Leader rule here. X go from 0 plus. X need to approach us 0 plus, because if this 0, x approaching 0, it can be negative 0.0001. And you know, negative number is not allowed in Ln, right? So it's not allowed in x. So be sure this 0 plus. And then we're gonna do the integral of, do the limit of x times Ln x, like that. So over this, to use our Loss-Leader rule, be sure you need a fraction here. So let me write as, I'm going to bring the Ln on the top. You will see why. Ln x over 1 over x. So far, you just get the original back, right? So this is a fraction now, so you can use our Loss-Leader rule. So over, I put the Ln x on the top because if you differentiate, you just get 1 over x. If you put it like x over 1 over Ln x, differentiate that, you still get Ln x on the numerator, on the denominator. So this is annoying. So be sure you need to put Ln on the top. Always gonna. So differentiate 1 over x, you get negative 1 over x squared, like that. So over, let me just divide by negative 1. Let me put a negative in front. Divided by negative 1 is the same as multiplied by negative 1, you know. And x approaching to 0 plus. And then multiply by x squared on both sides, you get x squared, and x squared. Let me just do it to you guys. They are cancelled, and then this and this, they cancelled to be x. So over, you just get this 0. So over, this is just equal to 0, like that. And then you're gonna subtract. Integrating 1, you get x. And then you're gonna evaluate from 0 to 1. So over, put 1 inside, you get negative 1, and then minus 0. So over, you just get, this is just equal to negative 1. From 0 to 1, like that. What's your Ln x? Going from 0 to 1, the integral of Ln x going from 0 to 1 is equal to negative 1. So we know that, I forget something, and this is not correct. the n should be 0, 1, 2, 3, 4, like that. And then dot dot dot. We call this set of number as our whole number. Whole number is symbol is like this. Whole number W. Let me just write down a W. I think this is okay. For whole number is mean the positive in. It means positive integers but 0. Let me just, whole number is just positive integer and then contain 0. Because 0 isn't a positive number or a negative number. So whole number is defined as positive integers and 0. And whole number doesn't mean negative number. Or you can call W as W. Let me show you. W is equal to our positive numbers, positive integer, I think, integers and then 0, or you can call this as our whole number. Whole number just means 0, 1, 2, 3, 4, like that. Or you can call this as non-negative integer. Non-negative integers, you know 0 is non-negative or non-positive. So this is a non-negative integer. So 0, 1, 2, 3, 4, just W. So over, let me just consider another integral, ln x power of 2 dx. Or you can write this as ln square x. I would like to write this more. I love to write ln square x more. Or ln power of 3, ln cube x, ln power of 4x. I would like to write this as this. Because sine square x, this is equal to sine x squared, right? Let me just write this as sine, the way as sine. Just put a square here. I think this is okay. And here is the deal. To integrate ln square x, I would like to use our DI method once again. Differentiating ln square x and then integrate 1, you get x. And then this, first you put a 2 here and then minus the power, you get 1. Power of 1 is just ln x. But don't forget to multiply by the derivative of ln x because of the chain rule. So for the derivative of ln x is just 1 over x. So multiply by 1 over x is the same as divided by x. So over you just get x times ln square x from 0 to 1. And then minus 2 times the integral of ln x from 0 to 1 dx, like that. So over here's the is an interesting part, and this is also gonna be 0 as well. Let me just write down as this. And then ln x, we do this already. Ln x, right? Ln x, the integral of ln x going from 0 to 1 is just equal to negative 1. So negative 2 times negative 1. So over, sorry, I split. So over you just get 2 here, right? 2. Let me show you why. Because if you put a 0 into it, so over you just first you get 0 and then minus, put 1 inside, you get ln 1 and then 0. The first part is 0 and then subtract, put 0 inside. It's gonna be in the determinant form. So you have to use a last bit rule. So let me just give it as ln square x and then over 1 over x, like that. And then use our last bit rule since you know that this is an indeterminate form. So over x approaching 0 plus, this is just 2 ln x over x. And then this differential 1 over x, you get negative 1 over x squared. And then divided by negative 1. Let me put a negative in front and then put a 2. Because 2 is a constant, put it outside the limit. And then over, we get this again, x squared here. And then so over you just get x times ln x, right? X times ln x. So x times ln x is what? It's just x times ln x. We already do it. so it's just 0, right? So over you just get 0. So no matter you try, if this power of 3, power of 4, power of 5, you still gonna get 0 here. So you can check this by your own. So this equal to 2. Let me show you another example. Ln x power of 3 dx. Let me just write down as this. Ln qx dx. Use our integration by partition method. Ln qx and then integrate 1, you get x. Differentiate this, you get 3 ln square x and then divided by x. So over you get x times ln qx from 0 to 1 and then subtract 3 times x and x, they are cancelled. So over you get ln square x from dx from 0 to 1. So over I show that this equal to 0, so never mind, just ignore it. So over this we already do it. So 2, right? The answers to this integral is 2. So negative 3 times 2, let me just do it really quick. So this equal to negative 6. And then another example, ln power of 4 x dx. These are DR method once again. Ln power of 4 x and then 4 times ln cubed x over x times ln power of 4 x minus 4 times x and x, they are cancelled. So over you just get ln cubed x dx here. So over you are from 0 to put 0 and 1 into it, you get 0, so minus 4. And then this integral is just equal to negative 6. So negative 6 times negative 4 is just 24. And our less, really the less, I'm going to give solutions to this. Ln power of nx from 0 to 1, like that. I'm not going to talk too much here. Ln, so x times ln power of 5x 0 to 1 minus 5 times ln dx 0, 1. So over 24 times 5 is just, this integral answers is 24. 24 times 5 is negative 125. Look at this number. 1. Let me just forget the negative first. 1, 2, 6, 24, and 125. It reminds me something. Yes. 1 factorial is just equal to 1. 2 factorial is equal to 2. 3 factorial is equal to 6. And the 4 factorial is equal to 24. And the 5 factorial is equal to 125, like that. So over, you can write the answers to this integral already. Ln x and the power of n dx, and whereas n is a whole number, and then this is just equal to 125. So this n factorial, right? 4. The answers to this integral is just n factorial is power factorial, like that. So this integral 4 factorial, the power 4 factorial is 24, and then this power of 5 factorial is 125. We have an n factorial like that. However, we need to care about the negative first. The integral of ln x from 0 to 1 is negative 1, and then square that, you get 2, and then power of 3 you get negative, and then 4. Look at, when this is square, you get 2. When this is an even number power, you get 2. When it's an odd number power, you get negative 6, negative 1. When this even, you get positive, and then odd, you get negative. So over, we should have a negative 1 here, and then power of n, like that. So over, you just get power of n. For example, check it. Ln power of 4x, you pretty much just get a power factorial, 4 factorial, you get 24. And then when this is an odd even number, you pretty much just negative 1 power of the, and since 4 is an even number, so negative 1 power of an even number, so it's gonna be 1. So 1 multiplied by 24, so it's 24. So ln power of 5x over, you just need to do the factorial of the power. 5 factorial, you get 125, and then the power is a number, so over you just get negative. So over, you can do it really quick. For example, from 0 to 1 and the ln power of 100x dx, you can put down, when this is ln x raised to n odd number, an even number, so you can just put down 130, just positive. 130 is too big, so I'm not going to write the answer is just 130. And then 0 to 1, L1 power of 99 xdx. So far you get, when Lnx is raised to an odd number from 0 to 1, so over you get negative 99 factorial, like that. So this is the solution of Ln power of nx from 0 to 1, whereas n are for all whole number, like that.